All right, so you've made the graph for the internal resistance of a battery, and the question is, what is the internal resistance of it? And so this is the enigmatic formula that IB gives us for internal resistance. So what this means is that if we have a cell that is like this, and then it's got like a little internal resistance R, and then it's connected to an external resistance that is big R. What this formula is telling us is that basically you're just saying V is IR. Okay, but if we look a little closer, so the resistance here is just the sum of the internal resistance and the external resistance, which isn't, I don't think that's terribly helpful, right? So let's distribute this thing. Okay, so let's go E is IR plus I times the internal resistance, right? Now, we could argue that the potential, the terminal voltage is really just this, okay? It's the voltage that this resistor sees is going to be IR, right? So if I solve that for IR, that's going to be the terminal voltage. And if I do that, it's just the actual intrinsic voltage of the cell minus the current times IR. Okay, so what I'm saying is if I attach a voltmeter to a battery and draw different amounts of current to it, I ought to get something that looks like this. The terminal voltage is going to be negative R times I, okay, plus the terminal voltage. Now, if we make this into a graph, the graph would look like this. Y equals mx plus b. So on a graph, the y-intercept will be the cell potential, or EMF, right? And then the opposite of the slope will be the internal resistance. Do you see that? Okay. So if we find the slope of that thing, the opposite of that slope will be that internal resistance. So let's take a look. Let's take a look at this. Okay, let's take a look at our sample data here. Now take a look at this. Notice that it is, we've got our formula here, right? This is our y-intercept is 6.02. So that is our cell potential, right? So in the second question, it says, how does the unloaded voltage compare to the voltage you measured in step 0, right? Well, the unloaded voltage is going to be 6.02. And I can tell you when I took this data, the voltmeter actually read 6.08. So the unloaded potential is 6.08, but here notice how that y-intercept is 6.02, okay? That y-intercept should be the cell potential, and they're different, and they always are, and I don't really know why. Okay, so let's take a look at that. Now, this is it. The internal resistance of the battery literally is this negative 3.36, okay? Which that seems kind of high, right? That seems a little bit high, but if you do a little search, if you do a little research, and this is the set of batteries that I think is from like 2017 or something like that. And if you do a little research, the internal resistance of an alkaline battery is anywhere from 0.1 to 0.9, right? So if we think about that, right, we had this thing is actually not just a single cell; it's actually 4 of these guys all together, right? It really is a battery, right? Okay. If each of these has a resistance of 0.9, well, 4 times 0.9 is 3.6, right? So these are on the high end, right? If you divide 3.36 by 4, you would get the internal resistance of each one. It doesn't seem to be out of line, right? So to answer the question, find the slope of your line and make the absolute value of that is your internal resistance, okay?